Hello and welcome to this live coding session presented by Jack Oberpfalz. Thank you very much for joining. I'm your host, Johannes Rabauer. And today I have a great guest from the UK. It's Les Jackson, staff developer advocate at Temporal. And we'll try to program a vacation approval system with Quarkus, LangChain4j, and of course, Temporal, and that will be the focus for today. As always, this is live and unscripted, so you can expect mistakes, but learning is pretty much guaranteed. And also, please ask questions or state doubts, but really any kind of feedback is always greatly appreciated. All right, let's welcome together Les Jackson.
Wow, round of applause. Wow, I wasn't expecting that. Yeah, good morning, good evening, good afternoon, everybody. Lovely to be here.
Yeah. Hi, Les. Thank you so much for being here.
Good pleasure.
You just came from a business trip, so you're a bit tired. I'm a bit tired, but we'll get through this and show the people what Temporal can do. But first of all, can you tell us a little bit about yourself?
Sure. So I won't go on too long. I don't think everybody is here for that, but yes, so hello everybody. My name is Les, as already been said. I'm a developer advocate for Temporal. I've been in technology since I left university, so that's way longer than probably a lot of your viewers have been alive. You can tell from the grey in my beard. So I've been around a long time. And in fact, you know, I remember using the very first release of Java when it came out. I was at university at the time. So that's how old I am, if you think back then. Although I'm not really, I'm not a Java developer. I've got a background in .NET, so that's what I focus in. But there's a lot of synergy with Java, so I should be okay, hopefully. Tonight we'll find out. Yeah, that's about it for me. So yeah, I work for Temporal. We'll talk a bit more about Temporal as I'm sure we move through the rest of the evening. Other than that, what do I enjoy doing? Well, I enjoy eating and drinking beer and eating cheese and cycling, all sorts of things. But yeah, I love coding more than anything, really. So that's it for me.
All right. Nice. Very nice. Okay. Yeah, so as you said, you're a .NET guy. You're actually not a Java guy, but I think can get through this together, and we'll use AI to code anyways, and then more or less look at the produced code, because then we just simply can do a lot more in this limited time frame.
That's right. I actually feel, you know, I'm a .NET guy. I'm very passionate about .NET. So I almost feel like I'm cheating on .NET by doing a Java video. I do my own YouTube channel where I just focus on .NET stuff. So yeah, to my usual audience, if anybody's watching, please forgive me. I've not defended Java.
All right. Thank you very much for cheating on .NET. Okay, but the main focus for today is Temporal anyway, and Temporal is agnostic of the programming language, basically. So first of all, give us a raw overview over Temporal. What is it and when do you use it?
Yes, good question. So we use this saying or this terminology, durable execution. So you'll hear people talking about Temporal as a durable execution platform, and a very marketing phrase that's used is your code will never fail if you use Temporal. Now, we all know that's not ever going to be the case. Code will always fail, but where Temporal comes into play is when code does fail, it helps your code recover really well and really elegantly without you as the developer having to do too much. We take care of that for you by and large. So what that means is you may have a service that crashes. When it restarts, the state is maintained externally with Temporal, and your service will keep going from where it crashed. So think about something like an agent loop. You don't lose your context of the conversation, things of that nature. And it's more than just that. It's really good at long-running processes. So thinking about something like, you know, an e-commerce domain, you may have a shipment workflow where something gets dispatched from a warehouse. That workflow can run for days or weeks, even depending where it goes through, you know, trying to deliver a package to somebody. So Temporal's really good at having these long running workflows that just sleep really elegantly and idly when they're not doing anything, but then reawaken when they need to do something. So durable execution helps your code recover when it fails.
Okay. So that's what I understood about Temporal, and that's where I got the idea of using Temporal with, for this example, LangChain4j, or really any kind of AI workflow, because these AI workflows tend to be not deterministic, and though they can fail more often than not.
Yep.
So I think this is an interesting combination to use Temporal to make sure that these workflows run.
Yeah, I mean, so Temporal is not just aimed at the AI domain, but hey, look where we are today. Everybody's talking about AI. It's the big thing. And so we've definitely positioned ourselves in that space as well to say we are really good at being, I guess the term people use a lot now is harness around your agent, so that we help it never fail. We help it not to fail, or if it does fail, we allow it to recover really elegantly. And you mentioned the word determinism, so we might cover that a bit later. I think you've got some other questions for me, and we'll delve into that a bit more, because that's a really interesting concept in Temporal, and I do want to clear up a misconception that sometimes comes into play there, but we'll maybe leave that for the moment.
All right. Okay. So, okay, this demo that we will show is a really small app, actually. And why should we use Temporal in this case? And when is Temporal overkill from your perspective?
Yeah, that's a really good question. And one thing I do want to say as well is Temporal is an open source framework aimed at developers, so I'm not trying to sell anything. I'm not a sales guy, so use it, don't use it, that's cool. There is a paid for version if you want to pay us to host it for you, but it's open source fundamentally. So I want to say that from the offset. And I'm a great believer in using the right tool for the right job. So some things are overkill, and Temporal may be overkill in some situations, such as very simple apps that are not calling any other external services. They might call something that you control internally within your organization. They're not long-running processes. They return a result really quickly. Probably overkill to use Temporal there, although you would have to look at what it was. If it's something that is mission critical that you do not want to fail, even if it's a really small app, Temporal might be applicable or usable. But when you start talking about you're calling external services, the classic distributed application is really where it's coming into play, long-running processes, and of course, things that you just don't want to fail, things that are critical to your organization running, then Temporal's a really good candidate. And so some of our customers who use the open source version don't pay us anything, or some customers do pay us. They run mission critical workloads like banking, all sorts of things like that. So if you're running stuff like that, those sort of workloads, Temporal's a good fit.
Okay. Yeah. And so for these small scope apps, I remember a project we had, and we wanted to do something, I think every night we had to do some kind of task, I don't know, image compression or something like this. And so we had to handle like cron jobs and job runners and stuff like that. How does Temporal compare to those? Is that something similar, or is that actually a different task that you use for those?
So one of the things we say to people when they're thinking about using Temporal is, if you don't use Temporal, then you're going to have to consider cron jobs and job runners and queues and all those architectural concepts. So again, you can build reliability and resilience into your applications. You can do that, and you don't use Temporal, but that's going to take a long time, and it's a lot of extra effort. It's not helping you to deliver business value, the unique value that you're delivering as a developer. So I always compare it if I'm doing a little application, I never write an authentication service. I outsource that to somebody else.
Yeah. Please do.
Absolutely critical thing, absolutely need it, but you're not going to write it yourself because someone's already done it. They've thought through all the hard use cases. It's what they do. It's what they're best at. So I'm going to outsource that to another vendor. So Temporal's plays in the durability space in the same way. So you can still use cron, all those kind of things, but I wouldn't even say it's a like-for-like replacement, but the functionality that you need cron for, we can replace that. But it's not a like-for-like replacement, and it's more than just a scheduled job. It's application orchestration, really, that almost sit above things like cron and job runners and stuff like that. So it's not a like-for-like replacement, but it does kind of negate the need for things like cron and things like that. Yeah.
Yeah. So it also handles recurring jobs, right? It's not just for jobs that are long running, but also like happen every morning, for example.
Yeah, you can do all that sort of stuff with it. Yeah, that's right. Yeah.
All right.
Yeah.
Okay. So what is the biggest misconception that people have about Temporal? Like they maybe they don't want to use it because one misconception they have, and it's actually very different from what they think.
Yeah, so this is me coming back to the determinism question.
Oh, yes.
So we're going into the temporal kind of primitives now, but the two main temporal primitives are the workflow, which is your business logic. So if you're talking about an agent loop, the agent loop would be your workflow, okay? And activities, that's the second primitive. Activities are calls to some other system. Now, workflows need to be, in temporal land, they need to be deterministic. They absolutely need to be deterministic. The activities are non-deterministic. And so the misconception is, as soon as people hear, oh, the workflow needs to be deterministic, that means I can't use it as an agent loop. Use case is not correct at all. So it's when you take the workflow and the activities together, they can absolutely form a non-deterministic system. But the workflow itself, the way that orchestrates things, that does need to be deterministic, because the whole value proposition of temporal is if that loop crashes, we need to be able to replay the events that happened up to the point that it crashed in order to restore state in a consistent way. And so the workflow itself needs to be deterministic, but it does still enable you to have non-deterministic overall systems. Again, that's maybe a bit abstract, but that's probably one of the biggest misconceptions I hear about quite a lot, especially now when we're talking about AI. And again, I think you need to use it to that is not necessarily an easy thing to grasp, from a 2-minute soundbite. You need to kind of play with the code yourself.
Yeah, so I have some questions for that, but maybe we'll shelve that for later. If we have a practical running example, then we can discuss that, because I don't fully understand what you mean by this is not deterministic. Okay. Yeah. So maybe one more thing. What is the most common mistake people make when using Temporal? So they want to use it, they implemented it, and then something goes wrong, and it's every time it's the same thing.
It's the same thing. That's a difficult one, to be honest with you. I think it's probably more. Yeah, it's not really a mistake. I would say it's probably, again, it's coming back to misconceptions. And I think one of the misconceptions around Temporal is people think Temporal executes your code and we somehow own your code. We don't. Your code runs how you want it to run, and you have to have the compute to run your workloads. Temporal just sits to the side and is aware of how your application is running in order for it to maintain state of your application. And it does perform an orchestration function. Again, that's kind of what it does, but it doesn't actually run or own your code. So not so much a mistake, but again, it's maybe more a misconception. In terms of mistakes, again, I'll come back to the deterministic thing. If you try and inject non-deterministic operations directly into a workflow, it won't run properly. You'll actually get a compile time error, or it will not execute. But again, when we come on to, that's probably the biggest mistake people make. Again, getting their head around this idea of deterministic workflows that contain non-deterministic activities. Yeah, that's probably the biggest mistake people make.
Okay. So we laid the foundation for understanding Temporal, and actually now I think we could go into just a demo and a bit of live coding.
Okay. Now, I hope you don't think I'm being rude. I'm moving you all onto my big screen. So I'm not, my camera's here, but I'm going to be looking at my big screen. So I'm not ignoring you. I'm just looking somewhere else.
All right. Good to know. Okay, so I did a little bit of preparation, but not too much. So I created a little repository here, and it actually has the structure and the Docker Compose stuff already implemented. So the idea is that we have this Java app with Quarkus and Qute as the UI, which is just very minimalistic. And this talks to Temporal as the workflow manager. And we also have a Docker Compose, a Docker container with the UI and the admin tools. I didn't even try those yet.
Okay. You've actually gone quite deep here, because I usually just run, there's a developer CLI that you can run. It just runs everything in the one thing, but you've decomposed it into the system. So yeah, you've done really well there. Yeah.
All right. Yeah, and that has PostgreSQL as a storage as well. And then we have Ollama, which runs a local LLM. I don't even know some kind of small LLM that runs on my PC. I think Llama 3.2 or something like this. Yeah, and that's it basically. Yeah, is there? Well, okay, this is the workflow. And like I said before, the idea is that we have, I just show the running app. I think that's easier to see.
Can you go back up to the first diagram?
Yep.
So just maybe for the viewers, you could almost, I think, simplify the three temporal boxes, because I don't want people to come away thinking, to get started, you actually have to have the temporal server. You do need the temporal server. You absolutely need that. Usually, if you're just running the dev tools, it's just one thing you need to run, and it has the UI in it and possibly the admin tools. I'm not sure, but just to have temporal working, you really just need the temporal server and the database. And again, if you're running the local CLI version, it just has a SQLite database. Now, obviously, if you're wanting to productionize things and run actual production workloads, then you can't use that, and you'd use something more like this, absolutely. So this is a more real world example. But the question, so that's point number one. So you really just need the temporal server to get up and running. But in terms of what's actually running the agent loop, is that the Quarkus box there? Is that what's actually is that executing the agent loops?
Yes, that is the business code is running in Quarkus, and it's actually calling with LangChain4j. It's calling Ollama for some tasks.
Okay, and so just again, temporal language, just so that people are kind of across it. If you're reading the docs at any point in time, that the Quarkus box would be called a worker in temporal land. Sorry, excuse me. There's a emergency somewhere near me. I don't know what it is, and hopefully you didn't hear that too much. But yeah. So whoever runs the workload is called a worker. Okay, so that's all I wanted to say there. So sorry to interrupt, but yeah.
Yeah, that will be exciting for me as well. So because I didn't quite understand how this connection is made between those two. So because temporal is basically it knows what to do or what to call, but Quarkus is doing the actual workload then. So I'm not sure.
Yeah. So you're responsible for your business workflow, whatever that happens to be. In this case, it sounds like it's an agent loop or something. So yeah, and really what that's doing is, well, we'll see. Maybe we jump into a demo and we maybe start looking at code and stuff like that. So
yeah, I think so too. All right. So all I did was now just call Docker Compose up build, and this little example does not use temporal yet, because I originally thought we could implement this, but actually now that I think of it, I think I'm not sure if we can get through manually coding the temporal integration. But
but yeah, I mean that's the way I would try and teach it. Is have non-temporal. You'll see it working, and then maybe try and crash it and see what that looks like. And then we can have a go at implementing Temporal, and you'll see what it looks like when it crashes then.
Yeah, right. That was my idea as well. So I did Docker Compose up. Now everything is running. And the idea is that maybe Jack, the employee, wants to have some vacation. And he wants to do this maybe 1 week. And his reason is, I don't know, holiday in Malibu, I don't know. And then he submits the request. And then the idea is that, first of all, the workflow checks if there is any overlapping request for this. So if there maybe Julie has a vacation plan for this for the same time, right? Mm-hmm. So this is the first thing that needs to be checked. And then the second one is actually AI related. So the AI is looking at this and trying to say if this is reasonable or not. Okay. Depending on some arbitrary rules, right?
It doesn't matter, yeah.
And this is already working, but you saw that it just takes a while because obviously this request takes a few seconds on my local machine. And then but the idea is that now me as a manager, I can comment and say, that's fine, I don't know, and approve that. And then, yeah, we have this. And the manager, the AI is also creating approval email to the employee. Okay, so this is all done without Temporal.
Okay.
And now the idea would be that, first of all, the check if it's overlapping, if any vacation time is overlapping, would be in Temporal, because that could take a few seconds at least to go over all employees and check if there is... Sorry?
Is that a separate service that you're calling to do that check, or what is that just internal to the workflow?
Okay. That is internal, and I think let's go through this. So we got the vacation request, the vacation service, and here we have a submitted vacation request. And the first thing it checks is find a conflict. So it goes through all of these vacation records and checks if there is a conflict, and then returns those.
Okay.
So that could be a task that takes some seconds and could be outsourced. As that was my idea, at least.
Yeah. So yes. So I mean, just trying to think about how you'd maybe compose it as a more of a distributed application. That would be an external, what we call it, vacation scheduler service or something that would sit in its own, container, whatever, and you'd call it via, a REST API interface or something like that. You would make that call so that the call to check the request is valid, it doesn't overlap, that would still be part of your workflow, your Temporal workflow.
Yeah.
Yep. Where the work is done to actually do the check, you could just keep it here, I suppose, but you may run into problems with this idea of determinism. So you probably want to outsource that to, or construct it as what we'd call an activity, and then you call the activity from the workflow. So anything that's non-deterministic that could return different answers anytime you call it, you'd want to wrap that as an activity. And usually that's a call to an external service, usually.
Huh. Okay, you say anything that is non-deterministic. I would say this is very deterministic, because there is no fuzzy logic in there. It's just checking if there is any overlap. Okay. So maybe you think of something else when you say a non-deterministic. You think of something else than me.
Yeah. So I was thinking more along the sort of at the platform level. If you put this into like its own API, that API can return a 200 OK with your response, or it could return a 503 bad gateway or something. So what I'm saying is anything external, even if you own it, and you're running it, it can still behave in a whole manner of random ways. The network might not be, available or whatever. So that's what I'm meaning by non-deterministic, not so much the operation itself, but that can also come into play as well. That's also a good example. But so the function itself is possibly non-deterministic, but even then, depending on when you ran it, say you ran it today, it might return one result, and then if you ran it tomorrow, it might return a different result. So that is giving you a different answer.
I think I get what you're saying now. So this is because this would be an external call. It might return a 200, or if you pull the plug somewhere in the system, it might not return 200, but not return at all or anything like this.
Exactly. So in order for us to replay it, replay it in the same way, we couldn't know that. By the virtue of the fact you've wrapped it as an activity, that's cool, that's fine. They can be totally non-deterministic, and we just store the result of whatever that activity returns, and that's okay, that's fine, that works okay. So maybe I shouldn't have mentioned it too much, because I think it's maybe going to confuse people more than it needs to. But the point is you can have what you're doing here part of your workflow.
So that probably was a misconception on my side. So Temporal works very well if you are using a microservice structure. Did I get that right? So if this find conflicts is a different service, then that's perfectly fine, or even good for Temporal, because it doesn't care what it's calling back.
Yeah, basically that's right. So one of the main use cases is distributed applications, and anybody's already written a small distributed application, they're difficult to write anyway when things work. And you're getting 200s all the time, still complicated, but when things start failing and there's dependencies on things happening, then you've got to deal with all of that failure, whereas Temporal can really help you with that.
Okay, but the way I designed it, everything is in one service now. Okay. So maybe that's okay. Not ideal.
I mean, that's okay. I think that's okay. I mean, so how are you calling your LLMs? That's a call to using an Ollama API or something like that?
Right. Through LangChain4j, we call the Ollama API, and then we get some kind of result. And that's, of course, that's what I meant with non-deterministic.
Yeah. So that was a definite candidate to wrap it in an activity for sure. 100%. That's what you would need to do here anyway. And I would still recommend that this particular internal function, I mean, you could call it like a tool or something like that, but and have it wrapped as an activity. So you could still have it here in your code without having to have a separate service for it, but I would wrap it in an activity. Yeah, for sure. This might be a good one for AI to go, look, hey, we are temporalizing this. We have calls to our LLM. We believe that's a good candidate for it, making it activities, which it would be. And this particular vacation request call, I would say is potentially a non-deterministic operation that you can call from your workflow, but it cannot execute inside the workflow. You need to wrap it in an activity, I think is what I would suggest would happen.
Okay, so this is the first step of this vacation request, and the next one is the actual AI call. So we got that advisor, which has the review method, and that is actually just an interface, and it's getting implemented by LangChain4j. So these are the messages, or no, this is the system message and the user message. Oh, sorry. What? That we give the LLM. Like I said, that's potential very different every time we call it. And especially with local LLMs, I had the problem that sometimes it just doesn't work at all, and we don't get a result or anything like this.
Yep.
Yeah. Okay, so this would be the second step for me. That is temporalizable. Something like that.
100%. This would be temporalizable.
Yeah, temporalizable. All right, that's a word.
Why not? Let's invent it and say it is. Yeah.
Okay, and then we have pending. I'm not sure. Oh, okay, and then we put this record with all that information that we now have into the pending hash map. Yeah, concurrent hash map. So, okay, this is the first step. And then the user has to decide. So this is pending, and we have that pending approval list here. So Jim wants to do a vacation as well. And maybe this is already overlapping, no reason. Then we have a pending approval. Yeah, and this takes a while just because it's calling the LLM.
Okay.
Okay.
Now, all of the results of what you're doing there, that's all stored in the process. It's in process stored, is it? Is a array?
I think in this example here, it's not even stored anywhere. It's just stored in that list.
Okay.
Which isn't ideal.
Yep. Okay. So, you know, the point I'll make here, just to maybe sort of elevate it and keep it kind of simple. If you crash the process that's running this and you restart it, what happens?
Yes.
Everything's gone. You've lost everything. And your viewers will then go, yeah, but when you just write it to a database, yeah, you could do that. But then when it recovers, you then have to recall it from the database and recall it in a way that it was in the same state that it was in when it crashed. You can do all of that, but do you want to? You know, do you want to be bothered writing all that stuff? You can do it 100%, but that's where Temporal would come in. This crashes. When it recovers, however you choose to recover it, it will go to Temporal. It will replay the workflow, assuming it's deterministic, and then it will just start from where you left off. So your two applications will be in the same request state that they were in before, and you don't need to worry about, oh, is it stored in a database, and then how is it recalled and all that stuff. Temporal does that for you.
So that's a great point for me. I would be very skeptical to put a request that has some user data in it to Temporal and then just be sure that it's never getting lost. But what you are saying is you can be sure of that because it has a database in the background. And even if everything crashes, this data is still in the database. And if Temporal boots back up, it has the workflows going and it has all the data that's necessary to work through those workflows. Yeah,
that's right. So under the covers, Temporal is basically, I don't know if you've heard of an event sourcing system. So it basically stores the events that are emitted from your workflow and just, you know, has that list in its database. And then when in the instance where a service crashes, those events will be replayed and ordering us to reconstruct the state of your service. So yes, absolutely, it's stored in whatever database you choose to implement with Temporal. And that's it. Now you might go, well, what if the database crashes? Well, yeah, I mean, yeah, anything's possible, but that's more a database problem, really. Temporal as a server could crash as well. I mean, you know, it's like you're never going to get any system that doesn't ever crash. But fundamentally, you know, for most workloads, the Temporal server's there, the database is pretty there, and if your service is, you know, not running particularly well, then yes, it just replays the stuff from the Temporal database. Yeah, and that, you know, again, I'm not being a salesman, but that is one of the reasons why people do tend to go with Temporal Cloud, which is the commercial offering, because we host everything and it's got high availability, and I think it's 5 nines or something. But again, it can't, you know, even then, there's no such thing as a 100% reliable system. If anybody claimed there was, you go rubbish, and that would be rubbish. There's no such thing. So, but for most use cases, vast majority, yes, it's a highly reliable way to maintain state of your application.
Yeah. All right, but let's say the vacation service ran through and your vacation is accepted. Then I would go on and write that to the database outside of Temporal, right? Because then the workflow is done. Temporal does not want to deal with this anymore, and we store it in the database.
Yeah, I mean, so yeah, that's a really good point, actually. So what I'm not saying, and you've got to be careful here, is saying that it replaces your databases as well. We're not saying that. I mean, you would still want to absolutely have your own database with, the requests and everything like that. Where Temporal is coming in is just when things fail, go wrong, then we can replay the state. It's like you don't need to worry about the state of your application is really where Temporal comes into play. We're not talking about replacing your data sources or anything like that. You'll still need all that however you want to do that. Yeah, for sure. Yeah.
All right. Okay, so that was that whole detour.
That was a good detail. Yeah, again, it's all these things. That's a really good one, actually. You know, maybe a misconception. Does it replace your databases? Not really. I mean, you could maybe. That would
yeah. All right. So let's say we have a pending request, and then the user decides what to do with it, and that should be in the decision here if it's approved and some comment with it. And depending on that decision, it should be. Yeah, it's just again put in a decided hash map. But also, creating that notification message through AI. So this is LangChain4j again, with some system message and some user data. Yeah, and that's it.
Okay.
I think that is really everything important here.
Okay. So, a couple of things then. Maybe if, again, just for people watching to kind of maybe try and get where Temporal would be useful. Say you run that again, and you take down Ollama. Just I guess you have it running as a local service. Kill that, and then see what happens when your application needs to make that call. It's going to just crash, and unless you've got retries built in, then it will just hang and fail. Again, Temporal can help with external calls. You define policies, and it will just retry until it succeeds, or until you want to give up. Point is that Temporal retries existed before Temporal. Temporal didn't invent retrying API calls. That's existed forever. But where Temporal is different is that it's not an in-process retry framework. So I'm not sure what the one in Java would be, but going back to .NET, if I was using a .NET popular retry framework, if my service crashed and it was in the middle of retrying, when it recovered, it would just go back to retry number 1 and start again. With Temporal, it wouldn't do that. It would only start retry. If you say you wanted to retry 10 times, your service crashed at retry 5. When it recovered, it would only start doing the last 5 retries. It wouldn't go back and start doing 10 again. So we didn't invent retries, but they're not in-process retries. They're fully durable retries. Hopefully that made sense. And that's point I would make. But the other thing as well is it's very simple to have retries as well. It's you just define policies that are just JSON basically, and you define how you want your service to be retried.
That will be exciting to see anyway. So to maybe just try this. So if I submit that request, we saw it takes a few seconds. In those few seconds, I could just stop Ollama here.
Yeah, you can see what happens.
And just see what happens. Yeah, let's do it. So this is loading, and Ollama should work. Yeah, and we get a nice internal server error.
again, that's the kind of thing that happens all the time. And you could deal with that using some kind of retry in here and not use Temporal for sure and handle that in a more elegant way. But the point is, Temporal will just kind of almost handle it for you without you even having to really do anything,
Yeah.
Sort of the case, yeah. So
cool.
Again, as a developer, the value proposition is saving you time. You could write all of it yourself, but it's just going to take you away from what you really need to do, which is write your application to do vacation planning, rather than writing all the boilerplate code to make it durable.
Yeah, and from what I saw in that quick demo I did, it's really easy to implement, and we get a nice little overview through the AI, through the UI.
Yes, exactly. Yeah,
so,
that's exactly right.
Okay, so what I would like to do is stop all of this. And then, because we have still time, I would like to do a new session with GitHub Copilot and simply tell it to temporalize the application.
Yeah, just say, can you, introduce it to, temporal. Yeah, I don't know if I'll understand temporalize, but And I used to use Copilot. I've kind of switched to Claude Code now. I guess you can give Copilot skills. Can you give it skills? And stuff?
Yeah. Sure.
So there is a temporal skill as well. So you can give it that, and it just makes it even better at doing temporal stuff. Most of these agents are still really good without it because it's quite a well-known product. But you give it the temporal developer skill, it will really do a much better job. So just thought I'd call that out as well. So.
Yeah, I'm just.
That's on the temporal GitHub area. So the temporal.
Let's do this.
GitHub.com.
Skill probably, right?
GitHub, the GitHub one, temporal skill. That's the one you want. Yeah.
And there's probably some NPX. Cool. Okay, I didn't know that. So let's go. Second.
And, it's just a good, while you're doing that, your viewers can see that, all the different SDKs we support generally is pretty much all the main high-level languages. So I'm sure most people are watching this are Java developers. So,
hopefully.
Yeah, hopefully. Maybe one or two .NET now. You never know. But
yeah. Oh, again, because IBM Bob is so rare. I always am excited to see it somewhere. So here's IBM Bob as well.
Yeah. Wow. Okay, that is quite. Been around a while though. I think.
No, it's been around. I think since February or March they released the version 1. So it's not.
I'm thinking in something else. Then there was I'm sure it was an IBM AI.
They had this Watson X, I think.
That's it.
But
Watson, that's it. Yeah, that's it.
Yeah, that was different.
Yeah, okay.
Why don't I see the right one? Huh? Okay, that is strange.
What is it you're looking for?
The GitHub Copilot? Am I missing it? Or what is this? Universal. Okay. Yeah. So we just press enter. Yeah, okay. Installation in that project. Yes, please. And then I think we have to reload that skill. Find skill. Is that the right one? No, I don't think so.
It's one of these things I don't do frequently, so
yeah, that's skills. Manage skills. Reload. Here we go. So stop this. Okay. Reloaded. Found 12 skills, and now we should have some temporal stuff here. Yeah, great. Okay, and now. Go ahead and temporalize. Let's try this.
Try it, yeah. Hope it doesn't do something totally random. Some other product realize that does something else. But, we'll find
This
out.
is in the But it should find that we set up Temporal as a Docker Compose setup, and that we are actually not using it. So that should be obvious.
It should say it won't take care of that for you. If not, it would usually do that. Yeah, it would then spin up an instance and all that kind of stuff.
What should be already done is the application properties, because that's the one area where you have to do some connectivity or input some data for Temporal to work. So we set the target location, the namespace, and the task queue for the worker.
That's it. Yeah.
I think that's all that there's.
Should be all to do. Should be all that you need. Yeah, that's right.
Yeah, and everything else is done with annotations. Sorry.
Yeah, that's right. Yeah, no, absolutely 100% correct. Yeah, and just at a high level, the way it works is like the worker will get work from the queue that you've specified, and the queue is defined on the Temporal server. So yeah, basically that one.
Okay, it's doing something with Temporal, so it kind of got what we want, I think.
Yeah. Okay. And you've got this under Git control, I assume, so we could even look at the differences in the code.
Absolutely. Oh, I got quite a few changes. Oh, wow. Okay. The skill is extensive, and it's all one single skill. That's interesting. So we got probably one skills MD file somewhere, yeah. And this all belongs to that one skill. I never saw that before.
I think you can exclude. So, I mean, there's obviously one specific for Java, and there's other ones for different things. So, I think you can trim it down a little bit.
Yeah, I mean, these are all small text files, so it doesn't really matter, I think.
Markdown, isn't it? Yeah. So.
It's just usually if I download these skills with npx, it's a bunch of skills and not just one single one with a lot of references.
Okay.
And that's interesting. I don't think it's a bad idea or something, because this is like ordered in with core and .NET, so the different languages are in different folders, and that's pretty cool. Okay, let's edit temporal skill. Let's lock that down already. Okay. It created the first activity. Let's see, does it say anything? No. So we can actually look at the activity.
There you go. The comment's interesting. The non-deterministic work of the vacation approval.
Yeah. Yeah, and asking the LLM for recommendation or notification draft.
And then each method is retried automatically by Temporal on failure. And yeah, you can define, in more detail how you want those retries to work, but there's a default policy. So demo purposes, it's probably fine.
Can I do this here in the?
I think you would. I think if you go, I don't know where it's done. You go to the workflow, the vacation approval workflow. I think the policies are actually would be defined in there, maybe.
Okay.
I need to look at the Java docs to see where you. It's maybe still doing it.
There's an unfinished policy. That's something.
Yeah, it looks like one. Yeah, that's it. Yeah, okay, one.
And we can abandon or warn and abandon.
usually it's things like the back-off coefficient and number of retries and all that stuff. So I think you can, maybe when it's finished, we'll just say, where are the retry policies for these calls, and like point to them.
Okay, but still, this is already really interesting. So these are the activities that we defined. Yep. This is the actual code that we already had. So this is probably not very different from before, because the business logic is the same.
Exactly right. So, I mean, that's a really excellent point. So, like, if you've written code to call APIs and all that sort of stuff, it will look pretty much exactly the same. Yeah. And that's all. So if you're using Temporal, yes, that you have to think about the mental model and the primitives, but your code doesn't really change dramatically. It's more about how you think about writing your code, but the code itself, certainly the activity code, would be pretty much identical. Yeah.
And I guess it still does put the decisions somewhere. But that's probably in the vacation service. Well, it's still working, so it's not done. So if you submit a vacation request, it now starts this workflow. Oh yeah, I'm pretty sure we can tweak this. Retry options, for example. So at that point,
it looks about right. And then you can define.
Yeah, okay. Default instance, or probably with. Oh. Yeah, okay. There are a lot of different things we can try.
Refer to the docs would be my answer on that one. There's quite extensive documentation.
Okay.
Some of the examples, but it'll just probably pick up a default one, and I think that retries infinite retries. I think by default, I can't remember.
All right. Yeah.
Which you may not want. Of course, you might want to try it 5 times and then call it quits. And that's the other thing. So talking about distributed applications and external services that you don't control, they may just fail, okay? And there's nothing you can do about that. So Temporal doesn't sprinkle magic dust on those and get them to magically work, okay? They are still down and will never work, let's say, for example. And so your workflow in this case would fail. Temporal's not failing, but your workflow would fail because it can't finish. But the good thing with Temporal is, if you're talking about distributed systems with multiple services you're calling, with Temporal, you can go into the user interface, which we've not looked at yet, and you can see exactly where your workflow failed, what process failed, and it just helps you with that observability into a really complex domain, and you can actually pin down exactly what failed and why. So even though some external service just failed, you can still see where it failed and then take whatever action you need to take. So it helps in that regard as well.
Yeah, I think that is really a big selling point, because that's something you don't do just for this one task that you, I don't know, let run in the night, every night, right? You don't implement all of this just to see what fails. And if you got that out of the box with Temporal, I think that's a big point why you could use this.
I'd want to use it, yeah, if nothing else. It's something that's often overlooked or sort of not, talked about as much, but it's definitely, code will fail, external services will fail.
Yep.
You can see, if anybody's ever watching this, you've been on call or you are on call, and if someone's screaming at you, trying to get you to find out why something's not working, it can be incredibly stressful. And so if you have a single place you can go to see what activity failed and understand why it failed, because you have all that information, it's saving you a lot of time as well,
Yeah.
And stress.
Okay, so we got one question, I think. So could we tell the Watch Smart how to make an app like that. So I guess we could use that to kind of show the docs really quickly, right? So if we go to Temporal, where would I go if I don't use AI?
Yeah, and I would actually really recommend you don't. So go to Docs, just along.
Here we go. Yeah.
Click on Docs, and then under Quick Starts, I'm pointing at the screen. You can't see on the left hand side. You've got all the SDKs that we support, and
oh yeah,
that will take you through a step-by-step get up and running with a really silly, simple application. And then I believe on this website there are more detailed examples. But if you actually want maybe more interesting code, then I would point you to GitHub. But it's a different GitHub area. So if you want to bring up GitHub, and I'll show you where I would go to. And it's actually not this repository, it's Temporal. Take off the IO at the end.
Yeah. What's the difference? Because I saw that from time to time. Yeah, that's not it.
That's ours. So Temporal, obviously somebody got there before us. So I think that's why we've had to call our main one Temporal IO. But if you take out the IO and put in a dash community, this is a really good place to find actual examples that people in the community have written for various languages and various use cases. There's actually quite a lot of AI stuff on here. And to be honest with you, if you actually go back to the main Temporal GitHub as well, I think there's lots of examples there too. There are lots of examples there as well. So both of those repositories, there are lots of examples where you can go and look at what people have built.
Yeah, that's the SDK.
That's the actual, SDKs itself. I'm sure there are in here. There are actual. I'm sure there's examples in this one. If not, go to the community one's the one I samples Java. Yeah. And it's probably got a folder with multiple things in there that you can try out.
Oh yeah, Spring Boot. Yeah. All right.
This is going through all the kind of concepts. It's maybe not like a full application, maybe, but it's definitely covering the core Temporal concept. So again, the community one is good because they are typically full apps that people have written and or showcasing.
Let's see here, the community. Yeah, there's not that much.
Not that many for Java. There's not that many for .NET either. Everybody seems to be using Python and TypeScript, I think it is.
All right.
Yeah.
Okay. That's great. We have another question. Hey, is it right to say that Temporal is event-oriented, such a tool to integrate different systems?
So it can be. I mean, it's as of itself an event sourcing system. So that's basically the sort of underlying architectural principle of Temporal. It's an event sourcing platform. So it stores events emitted by your workflows, which you don't really need to worry about how it does that. And you can look into how it does that. It's open source, so you can see how all that works. But is it event oriented? Yeah, I mean, maybe you want to know a bit more about your question. I'm not sure I answered it very well there, but certainly it is aimed at distributed systems that, as we all know, they are event driven more often than not.
Okay, so what I did was just went ahead and set Docker Compose up, and it went up.
Okay, right, okay.
Sorry. So the GitHub Copilot finished. I mean, we basically saw what it did. So it created that workflow and a couple of activities, and it changed the service a bit.
Cool. What would be good is to get the Temporal user interface up and running, and we've talked a bit about it and we've not seen it yet, so it might be very good to take a look at that. And
let's see. Okay, so the app is running, and let's try it one more time. I don't know.
Is Olama still up, or is it down, or what's happened with it?
It's up. So the Docker. Yeah, I didn't even show the compose. So this Docker Compose is building or is starting up a PostgreSQL, the Temporal core service. the admin tools, the UI as different containers. And then it also starts up Ollama. Let's see what, oh yeah, with what model? Llama 3.23 billion parameters. Yeah, so Ollama is also running in the Docker, and it's also using my GPU to make it a bit faster.
Well, I tell you what, it's running not too bad at all, actually. So you must have an okay GPU.
Yeah, I think I have about 7 gigabytes of RAM.
Yeah.
So that's just enough for it. And then it's running quite fast, actually. That's pretty cool.
Okay, to be honest with you. So
yeah. Okay, and we got that app, the Quarkus app, and the network volumes, yeah, all that stuff. But the app is actually defined in that Docker file. So it's with that first layer, it's building the Java application, and then with the second layer, it's actually starting it. So everything we want to do is done with Docker Compose up, and then you have to say -- build, and then it also builds that Java project new.
Okay.
Which is pretty neat, I think, because every time I do this with all my project, because then after years, I come to that project again and I simply call Docker Compose up, and it's doing everything I want, right?
Yeah.
Right. Okay. We got Tris. She wants to go on holiday in England. Let's do that. And if we submit a request, then we see nothing is getting done right away. I saw the pending request really quickly. Now it's
gone.
Now it's gone.
Can you just open up the Temporal UI? I just want to see
Yes.
what's happening in there. You know, it'll be interesting to see what's
right. So that should be here. 1 second.
Okay, so what you're seeing here are 2 workflows failed.
Yeah.
Don't know why they failed, but you can drill in and have a look. So
yep. Okay. That's Steve. That's from before.
Okay.
Why is this?
Wonder
we didn't input Steve this time. I wonder where.
Go to the workflow above, just see if it has the one that you just did. If you sort of hit back.
Yeah,
that one there.
This one. This one should be Tris. Yeah, it is. Yeah, okay. Activate request.
And scroll down a bit into the event history so you can see the different things that happen. So workflow execution fail, workflow activity tab.
So the find conflicts worked, right?
Looks like it, yeah. Yeah.
And then the review request for Ollama, that one failed.
Failed, yeah.
And now it says why it failed. Request scoped context was not active. Yeah, okay. Let's
throw that at the LLM, see what it does.
Yeah. I would like to see, did we use the activate request context? I don't think so. No. Let's just commit this just so we can see clearly the difference. First, try to use Temporal. And now we put that in the LangChain4j request failed in Temporal.
Now, I'm just thinking, before we started doing you started doing the coding, I'm always a bit skeptical of using a coding agent to do like a big bang change like that. Even though this is maybe not the biggest one, I'm still a bit skeptical of it because I feel you get stuff like this. I'm wondering if maybe, just maybe for your people watching, maybe what we could do if we were to do it again is to ask the agent, can you produce a plan for how you would migrate this existing application? What would that look like conceptually if it was, running under Temporal? And can you make a plan from? And I find when you get it to do that, you tend to get better results, especially if you then just iterate around the plan. You don't do the whole plan. You just go through if it's possible to do bits at a time. Not always possible to do that, but do it incrementally.
Absolutely.
Big bang stuff.
Yeah. You're absolutely right. And I usually do this as well, but I thought this was such a small scope that it could do that without a lot of planning and scheming. I just wanted to see if the skill was used, and by the looks of it, loaded skill temporal developer. So it did load the skill.
Okay.
That's good to know.
Yeah.
And now, okay. So this seems more like a Quarkus issue. Not inside an HTTP request, so no request context is active. Okay, that's actually what the error message suggested as well, that we activate request context.
And I'll apologize to your viewers. I'm not really familiar with Quarkus and things like that. So I'm glad we've got an LLM and your good self here as well to help navigate us through it, So.
Yeah, that's completely fine. For me, Temporal is quite new, so I'm not the expert here. But we'll get through.
Yeah,
with AI.
I'm confident it will. But yeah, going back to the UI, I mean, it's maybe a bit difficult to see, but each activity occurs as a discrete, thing on that timeline. And even, you saw here how useful it was to actually drill in and see what failed. You've got all that.
Yeah. Go ahead.
I was just going to say, again, you can get to where things errored outside of Temporal. I'm not claiming it, again, it invented this whole concept, but again, coming back to the point where you've got lots of services being called, it's one place you can come to see the thing and drill in and try and get to the root cause. So
yeah. What we do a lot of times is use Grafana, and there's a tempo for it, where you kind of see a similar timeline and see every.
Right.
I think it's called something else. I'm not sure what the term is, but it's similar to these activities, and you can see all of those. How long they took and what worked, what didn't work, and so on. So this is very similar to this, I think. Okay, it's finished. Build pass as well. Yeah, it passed before.
It did pass
But
before.
let's just try it once more. So we kill all of this. And then build it anew. And I wanted to see what it actually changed. Okay, it added that activate request context for the two requests that used LangChain4j or Olama. I think that could work.
We will find out.
Yeah. Not really sure why it has to download something now. because we did not change the POM. What did it download? Something from Maven. Did it implement tests? But those were here before. Strange. Quite strange. Anyway, I think it's done. Yes, it's ready. Let's try it again. Tom. We did not have Tom yet. Again. Reason again. Okay, we got Tom here. Yes. And we got this this first evaluation of the AI. And now it would be interesting to see this again.
So it's still running. It's cool. It's not finished yet. Yeah.
But it's not really active.
It's not active, no. So this is just sitting in a waiting state.
Oh, let's see that again, because we have only one workflow, right? That's the reason. Yeah, okay. We have one workflow, and that also includes our human interaction. So now the workflow is still running, but it's waiting for some kind of
signal
feedback, signal from the user.
Yeah,
and that's so why it says
human, human in the loop scenario. Yeah, and
signal. Okay.
And so this is how Temporal manages like exceedingly long-running processes. That could basically now run forever, basically waiting there, and then you just inject a signal when you want to then do something, and it will then do something. Yeah.
Now that's really interesting to me. If we stop the whole system now and restart it, it should be still there, right? It should still wait for us.
Don't kill the whole temporal thing, but if you killed your worker process and then restarted it, it will, should do.
So just our application, you mean?
Yeah. So kill it, and you'll probably see in the Temporal UI that there's no worker available to run the. Let's see.
Well, it doesn't do anything right now.
No, right? So it will still be running from a temporal perspective. It's still running, but I thought it may have complained that there's no worker available to. Yeah, so you can see along the top there, it does think there is still a worker there.
Ah, okay. So maybe we have to wait for a timeout or something.
No, unless there's something else running the workflow. But
it shouldn't.
Shouldn't be. No.
What's the no?
Okay. Yeah, maybe. So what would be interesting then is if you maybe try and use the user interface. The user interface is part of that process as well, isn't it? So if you try,
yes.
Okay. So if your user interface was a separate thing and it was still active, you could hit review, and it would just hang probably, but then you could recover your.
That would be my next check. So if we now approve that vacation request, it should call the LangChain4j again.
It should just continue from where you got to here. It shouldn't do any additional calls.
Okay. Yeah. That's the first thing now. So this is running again. No. Yeah, this is running again. And we got our user interface. We have Tom. And what I would try to do now is approve it and then kill Olama again. Because then Temporal...
Yeah, you can do that. Yeah.
All right.
I was going to just run through this one and make sure this is okay, and
Okay.
you know, not lost context. You know,
Let's
and
do
then,
this.
and then we can try the.
Yeah. Okay, so I approved that one, and it got HR assistant's name. Perfect.
You see that in production systems anyway. It's fine.
Okay.
Your worker died, you know, but you restored it, and you know when you were in a position to prove it, it just went again. You know, you didn't have to go back to the start, make the first
Right.
LLM call again. That's costing you money. If you're doing that over millions of, you know, or hundreds of thousands of requests, all stacks up. So again, there's a cost saving potentially there as well, you know, by having that state, you know, stored offline, making your agent durable.
Yeah. Okay, so this workflow is completed. We can see how long what takes. So this is actually a bit distracting that it took such a long time.
Yeah, because if you look at the side, that's the signal, that kind of magenta purpley thing. That's the signal that was injected, the human in the loop signal that the workflow to keep going, you know.
And this was the review request that took, how long did it take? Do we see this here? Here we go. 8 seconds. So that was the time that LangChain4j needed to create that text. And then for the draft notification, it only took 1 second.
And you can see there the retry policy that's been applied. You can see retry policy maximum attempts 3.
Yeah.
Blah blah. That's what's, you know, been implemented.
Yeah, and that's great. That's really useful. And also this the input and the results, of course. I think that's one of the most valuable things as well.
Yeah.
To actually see what's being sent. Cool. And now one more thing I want to test is if Jim submits a request and then Olama dies.
The only thing is, if it's three retry attempts, you'll at least get retries, but it will probably, you know, fail quite quickly. Yeah, but anyway, give it a go, and you should see it retrying and nothing else. That's a good test.
Right. So submit this, and then we stop Olama in time, hopefully. Damn it, it was too fast.
Let's check it. Okay. Yeah, okay, I did it. Yeah, okay.
Well, yeah, okay. So the 8 seconds was just because it was warming up.
Warming up, yeah. You can it's still done now though, because you don't. Isn't there a second one that happens? So it's still you're still gonna see a retry.
Oh yeah, yeah, you're right. So if we approve this, then it actually should. Then it should call. Yeah. Nice. Live view. And so after the third one, it probably will cancel that one.
It will fail it out, yeah, and the workflow will probably fail. But you could set the retries to more than that, and restart Olama, and it will succeed and keep going, and it's a retry. But again, the point here is if you crashed your process now as well, when you restarted it, it would restart your retries at whatever point it crashed the second retry. It wouldn't go back and retry, you know, 3 times again. So that's one of the main differences between in-process retry frameworks. So
yeah, I see. So that failed. And what happened now? It's gone.
Yeah, I mean, you'd have to obviously cater for that in your UI, I guess. Or something.
Yeah.
Do that, but yeah.
But there probably are a lot of options that we could put in here to, for example, just never stop
100%
retrying.
Infinite retries, and then that'd be a good one to do, and then bring Olama back up, and you'll see it come back up, and everyone's happy to get to go on holiday.
Yeah.
Maybe not England, maybe somewhere a bit nicer. England's okay. England's nice. Most of the time. Very hot at the moment, actually. It's really, really warm. So
yeah. All right.
I was in Portugal. As you said at the start, I was in Portugal for a work thing, and it was colder in Portugal than it was in England. That's very bizarre.
Wow. So, all right. Okay. Can we put -1 default is set to 0?
Yeah.
But that wasn't the case.
No, it didn't look like it. Yeah, unless, so I think you can have retry policies at the activity level, and I think you can also have them at the workflow level as well. So maybe there's an override there or something. Yeah, just a, you know.
So the activities. Well, yeah. No, we already checked that. I think with the annotations, there is not much options. So this is the workflow. Yeah, well, I think I saw what I wanted to see. So it did retry. It's more robust that way, the workflow, and you can do a lot of options to actually adjust it the way you want to have it behave.
And it's very simple. It's just annotations, not annotations, but yeah, it's just finding an object or something like that. It's not anything more than that.
That is true. So the setup that I had, at least, that was a bit overkill, probably, with all that stuff.
Maybe if you're just for getting started, yeah, I would use the download. It's called the Temporal CLI, and Mac, Windows, Linux, and but this is nice though. This is a good example for people. So if you're wanting to self-host it and think about having a more production grade setup, this is definitely where you'd start to think about it. But yeah, just to get started, you don't need this. No, you don't need to go to that level.
But anyway, so if you got this, the actual integration into Quarkus, I guess it's probably almost the same for Spring as well, is really simple. So we got couple of annotations in the workflow. Here, the workflow interface, workflow method, query method, signal method.
So query, as the name would suggest, is just reading what's the current state. So I'm not sure what part of the application is doing that. Possibly the UI is retrieving state at some point. But yeah, vacation record, get record, that's what it's doing. Yeah, okay.
Yeah. Oh, hi, Buhaki. If you wish to apply a retry to LangChain4j's chat model, set their retry to 0. Otherwise, it will be called on top of your retry service. That's a good point. Okay.
Yep.
So because we're using LangChain4j, it should be here somewhere.
It's a really good point, yeah, because I mean, there's one of the examples in Python using the Open AI SDK, and very clear that you only use the temporal retries, you don't use the OpenAI SDK retries. So if I've understood the comment correctly, I think that's what we're saying.
Yeah, I'm just trying to sort this. Yeah, here we go, right? This is one. No. Give me a second. I'm just wondering where this LangChain4j call is now. It used to be here. this is the find conflict. Yeah, review request. Here we go. Whew. Okay. So actually, this is calling LangChain4j, and I think Buhaki is saying that if we don't configure this like we didn't do anything here, it will retry as well.
Yeah, you don't. Yeah, it's a really good point. You only want retries to happen one place, one thing doing it. Yeah.
Yeah. Yeah.
Going to, going to use Temporal. Yeah, I'd advise you go with Temporal. Yeah.
I'm not sure if Max, if we can set it here. Oh yeah, retry. Nah. Okay. Somehow you can change that quite easily as well.
Comment, though. Yeah.
Yeah. All right. So that was great. I think I'm pretty satisfied with the solution we got.
Yeah, I think it's good. I think start small, but still it's big enough to be doing something. And yeah, and I think it introduced the main concepts: workflows, activities, signals, workers, the kind of high-level architecture. So a lot to cover in an hour and a half. Done well. So you're a great host. You got us through it really well. So
thank you. The AI worked quite well. So that's good. Okay, so are there any questions from the audience or not? Otherwise, thank you very much for watching, and thank you so much, Les, for joining, even though I know you're tired. But it was a great learning experience for me. And yeah, I think I will keep Temporal in mind for future applications, because I think it's actually something that is quite useful, and I did not have that on my mental map of tools to use, right? Okay, Buraki is saying if you declaratively create a chat model. Yeah. Okay. But I would rather use the annotations for this example. But yeah, if you have some specific things you want to change in LangChain4j, you have to go to the Java code and just write some declarative code. Yeah. Okay, Les, do you have any last words?
Any last words of wisdom? Well, just thank you for having me. You said you learned a lot. I learned a lot as well. And I think I'm definitely going to pick up a bit of Java again and just expand
very well.
I'm not going to cheat on .NET though. That's still my number one. But I will
you can code in Java in secret. Okay, that's enough.
That's right. On the side. But no, thank you so much for inviting me, and it was a real pleasure giving me the opportunity to talk a little bit about Temporal. So thank you.
Wonderful. Hey, and Les, if you ever want to come to Germany, we have a conference called JCon. It's Java centered, but since Temporal is agnostic to that, maybe you would like to join next year. I think it's in April, so maybe we can see each other there.
Definitely, yeah, that sounds great. JCon. Fantastic. I'll make a note of that.
JCon Europe is in Cologne, in Germany.
In Cologne. Okay. I've never been to Cologne, so that's even more of a reason.
Perfect.
So,
yeah. Amazing.
And maybe by that time I'll have done more Java and I'll be more of an expert by then. I doubt it, but
see, that would be perfect.
I wouldn't hold your breath, but yeah, I'd love to come though. Yeah.
Cool. Great. Thank you so much. And yeah, hopefully see you next time.
See you next time.
Bye.
Thanks all. Bye.